Hello everybody, and in this week's lessons we're going to be talking about angles and triangles, and we're going to split this up into several parts because of the amount of content we're going to want to cover, but we're going to go ahead and get started. Now, this topic on angles and triangles has a lot of very valuable and very important vocabulary that you'll be getting out of your notes mostly, but we will introduce some of it here. In this video part 1, we're going to be focusing on a few main things. As you can see here, we're going to be focusing on some specific types of angles. We're going to learn something about triangle side lengths, and then we're also going to discuss triangle angle sums, specifically of their interior angles. Let's go ahead and get started. And we're going to start by talking about different types of angles. Now, we should already be familiar with quite a few types of angles, such as acute or obtuse or right angles, but we're actually going to be talking about groupings of angles or pairs of angles and some specific types of those. The first type we'll talk about are called adjacent angles. Now, adjacent is a word that we use in everyday language, and typically we tend to describe adjacent as meaning something that is side by side or next to each other. But more specifically than that, generally speaking, adjacent items or adjacent figures, they tend to have something in common. They tend to share some part of themselves. For example, it is possible that your bedroom is adjacent to a sibling's bedroom. Now, of course, they might not be the same room, but they might, for example, have a wall between them. Or you might have a kitchen that is adjacent to a living room. There are two rooms that are next to each other, but they might have something, a wall or a barrier somehow that is shared between them. And that's kind of what we mean when we talk about adjacent angles. So looking at some actual angles, we might have an angle loosely like this. And of course, an angle is formed by two rays that have this common endpoint, and I'm going to call this first one just angle 1 to keep things straightforward. But then next to it, we might also have a second angle. Could be of the same size, of a different size, larger, smaller, anything else. I'm just going to call this angle 2. Now that we have these two angles that are next to each other, this would be an example of adjacent angles. Now, the reason that they are adjacent is because, again, they share that barrier between them right here. This ray that connects both of those angles, as well as this common endpoint, that's what makes these adjacent angles. If they had overlapped, if there had been gaps between them, if, in other words, they didn't, again, both share that common ray and a common endpoint, both of those features, then we wouldn't necessarily call them adjacent. Now, there are some special pairs of adjacent angles that we'll talk about later on, but this is a good starting point for us. Next, we'll talk about vertical angles, which some of you should be familiar with already. Now, the naming of these is a little confusing to some because the word vertical is familiar to many of us, but typically when we think of the word vertical, we think of a measurement or a distance or some description referring to the direction of being up or down or in those general ways. However, vertical angles doesn't necessarily just refer to angles that are, again, up and down. Vertical angles can be described as opposite and congruent. Now, when we say opposite, what we're going to talk about is that they are on opposite sides of a vertex, and that'll look something like this. We need to start with two lines that intersect each other. Something like this. And these lines can intersect each other at any angle that they wish, but as long as one line crosses another line, you're going to end up with a scenario where you have vertical angles. Now, the result of this is actually 4 angles, which we'll highlight here for you. We have this first angle up here, again, an angle being the measurement of rotation between these areas, but that red space, and this time I'm going to call this first one angle 1, and then we have, as we move in a circular fashion, angle 2. Down here we have angle 3, and finally over on the right hand side we have angle 4. Now again, the orientation of this picture doesn't matter if I were to spin it another way, as long as you have a line crossing or intersecting another line, this situation works out. And now that we can see all of the angles, it's time to identify the pairs of angles that make vertical angles. Again, they must be opposite of each other, but by default that also means they'll be congruent or the same exact size, which is a really, really helpful piece of information. So the angles that are on the opposite sides of this vertex, the intersection of those two lines, would be angles 1 and angle 3. Take note that angle 1 up here at the top and 3 here at the bottom, they are on opposite sides of that vertex. The only thing they have in common is actually the vertex itself. The sides of the angle don't actually overlap like they did with adjacents. This also means that if we look at angle 2 and angle 4, which are again on opposite sides of the vertex, that angle 2 and angle 4 are also vertical angles, meaning they are also congruent as well. So these are our first special types of angles. Adjacent angles, again, being side by side, that can have special features, but typically we use this type of scenario up here because we're trying to create some maybe angle sum total. We're trying to add things together or subtract them to find some missing piece of information. When we have vertical angles like we see here at the bottom, it's because we're able to use the fact that they are congruent to each other to again find some missing information. Next, we're going to see some other special pairs of angles that have very specific combinations. Next, we'll review complementary and supplementary angles. So, of course, these words are a little intimidating just by their sheer size, but we can use a variety of methods to help us remember what they mean. The first thing to take note of is complementary, which is a word that isn't all too unfamiliar, but just, again, be very clear on the spelling because we have another word that would have an I right here. And if we spelled it that way, being complementary would be like saying something nice about someone else. That's not the kind of complementary, obviously, we were referring to here. Our meaning for complementary angles is simply a set of angles that has a sum of 90 degrees. 90 degrees is, of course, a very special measurement because 90 degrees makes a right angle, again, a very specific type of angle, and that happens a lot in mathematics, or it's an important reference point at least, so we'll see some examples of that in a moment. We're going to go ahead and talk about supplementary angles, though, which will still have a similar idea, meaning we are going to add some things up here. Supplementary angles do have a sum, not of 90, but this time of 180 degrees. Again, another very special measurement. Now, of course, a 180 degree angle would actually be called a straight angle, meaning it'll look like a straight line. So when we have complementary angles, we'll have angles that when they get combined together will have an exact sum of 90 degrees. And if we have supplementary angles, they have to have an exact sum of 180 degrees. Those numbers aren't negotiable, and we can't simply just get close to them. We need those exact sums, otherwise they can't get these titles. One of the ways that you'll explore complementary and supplementary angles or make use of these facts is by looking at pictures like this. So here we have two angles immediately next to or adjacent to each other. One has a measure of 30 degrees and the other has a measure of 60 degrees because 30 plus 60 does in fact equal 90 degrees. This would make a complementary pair of angles. Now, it's not necessarily an always requirement that they are adjacent like these two are here, but it is a common situation that we will run across. They won't always necessarily give you a picture as well. They might ask you just to focus on the size or the measure of the angles, and they might just give you angle measurements for you to test that sum of those two values. We can also use this information to help us solve problems like this. In a situation like this, they might give us some missing information and ask us to use what we know about complementary angle pairs to find that missing information. And because we know that complementary angles have a sum of 90 degrees, I could write a simple equation as follows. I know these two angles would be added up, so I'll take x degrees plus 52 degrees, and knowing that they are complementary, I'd say that they should have a total sum of 90 degrees. In this way, we could use a little bit of algebra then to simply solve for our missing value, which is a pretty common way for us to make use of this information. Now, again, overall, while the algebra itself or independently might not seem overly taxing, keep in mind that we can identify these as a complementary pair of angles, because when the angles are together, like they are in this picture, their outer edges, the edges that they don't share, they're what form that 90-degree angle that is so important to that definition. We're going to use that same idea now to look at supplementary angles. So here we have a pair of supplementary angles with a missing piece of information that we would need to find. But again, just to make sure we understand what it is that makes these supplementary, is that they have a sum of 180 degrees, which is the definition of a straight angle. In other words, if we ignore the side just momentarily that connects these two angles, what you actually see is that the other sides of the angles that are not shared actually come together at the bottom to form what looks like a straight line. Now again, it doesn't always have to be, quote, on the bottom. We could turn this picture a lot of ways, but if two angles come together and form a straight angle with their non-shared or non-common sides, that's what a supplementary pair really looks like. Of course, in this scenario, we can use what we know, which is that the sum of these two angles, x plus 130 degrees, would equal 180 degrees because they are supplementary. And then we'd use a little bit of algebra to finish this out, which of course you could try on your own at this point. Next, we're going to take a look at some triangles and some of their unique properties. So the first thing we'll take a look at are triangle side lengths. So we can see our triangle here. And there's a very important, albeit relatively straightforward rule about the lengths of triangle sides. And that rule says the following: the sum of any two side lengths must be greater than the third side length. And that rule is true all by itself without really any alteration at all. However, generally speaking, it's easiest for us to use the two shorter side lengths, as long as the two shortest side lengths, when we take their sum, are greater than the longest side length. That's a very straightforward way for us to check this. Here's an example. When we look at the measurements now listed on this triangle here, we see that the two shortest side lengths are 3 and 4 units long. So the rule here says that the sum of any two side lengths, including the shortest ones I picked here, they must be greater than the third side length in this case, which is 5 units. So they're asking if this actually ends up to be a true statement. So we are going to test that one out. Of course, 3 plus 4 is actually 7 units, and 7 in fact is greater than 5. So what this can help us do is prove if these side lengths would actually come together to make a triangle. However, if we now used a triangle like this with these side length measurements and tried to test this again, asking, would a triangle even be a triangle if the side lengths are 2, 3, and 5? Well, we would take any two of our sides, again the shortest being one of our best options here, and take 2 units plus 3 units, and ask, is that actually greater than 5 units? And we can simplify and make 2 plus 3 the same as 5, and ask ourselves, is 5 greater than 5? And of course the answer is no, that's not an accurate statement. And since that's the case, this actually wouldn't come together to be a triangle at all. So you'll be using that idea to not only test triangles, but examine them in different ways. The last thing we'll talk about in this video is the triangle interior angle sum, which says this: the sum of the interior angles in a triangle is always exactly 180 degrees. In this picture here, the 3 angles listed are 95 degrees, 25 degrees, and 60 degrees. And if we take their sum or add them together, they will come out to be a total of 180 degrees exactly. What's interesting is what else this angle sum can tell us about triangles. For example, if the angle sum of a triangle is 180 degrees, then that means that those three angles, for example, here again we have 95 degrees, 25 degrees, and 60 degrees, those three angles could create an infinite number of triangles. Now you might ask, well, how could I possibly create an infinite number of triangles? And that goes back to our recent work with similar figures. We could always make this triangle similar but larger or smaller because that wouldn't change the actual angle measures. So again, if the angle sum is 180 degrees, then you could create an infinite number of triangles. On that same token, though, if the angle sum does not equal 180 degrees, if it were to create, for example, 179 degrees or 191 or 150 or anything else that is not equal to 180 degrees, then simply put, you would get no triangles at all. If the angles don't add up to exactly 180 degrees, what ends up happening is that you actually won't create an effective polygon. You'd end up with a open figure, meaning all of the corners wouldn't match, or you'd have side lengths that overlap, which also does not fit the definition of a polygon. So if it doesn't equal 180 degrees, then you won't have a triangle at all. The last situation that could happen is that when we are describing triangles, sometimes we like to describe not just the angles but the side lengths as well. So sometimes they'll describe the following. They could describe two sides of the triangle. For example, here we might label one side 5 units and another side 8 units. And the angle between them, which you'll see here, is labeled as 25 degrees. In this situation, they're describing a scenario in which you can only end up with one unique triangle. So if they give you that kind of description, just be careful of understanding that they are describing one specific triangle and not just a generic one for you. So you have to keep in mind again that the angle sum for a triangle is always going to be 180 degrees, no matter the type of triangle it is. If the angles add up to 180 degrees, you could create an infinite number of triangles. If you end up with an angle sum that does not equal 180 degrees, you'll get no triangles at all. Or again, in this last scenario, if they label two sides and then the angle between those two sides, they're describing one very specific triangle to you. So in short, that's everything that we will be going through in the first part of your week. Again, those things were types of angles, like adjacent and vertical, and complementary and supplementary. We talked about triangle sides, and how any two sides of the triangle must have a sum that is greater than the third. And finally, the triangle angle sum, which means that in order for a figure to be a triangle, it must have an interior angle sum of 180 degrees exactly, along with some other special circumstances. Go ahead and check out part 2 when you are ready. Rewatch this video as often as you need to, and do make sure that you take your time going through the lessons where you'll get even more detail and some great practice problems to help you put all of this together. Good luck, guys, and we'll talk soon.